Welcome to Math 95, Section 4.3. We're going to be using the systems of equations that we looked at in Section 4.1 to create models for solving some application problems. This will take us quite a while. These are pretty lengthy questions, so we will go ahead and get started. Our focus in this section is going to be on the problem-solving process, all of the steps that are needed, as well as using that new form of solving problems, solving systems of equations, to solve the models that we are going to create. So first I'm going to have you read this problem. I'll give you a few moments to do so. Now, as you're reading this, it might seem a little overwhelming and confusing. We have many things going on in this problem. So what I'd like to talk you through is a way to simplify what it is that you're reading so that you know what to do. So the first thing I'd like to do is I'd like to figure out what my variables are. And to do so, I want to find the question present in the problem. So this sentence right here is highlighting the thing that it is that we're wanting to find. So we have two types of ticket, and I want to know how much does each type of the ticket cost. So that phrase right there is going to tell us what our variables are. So the first step in solving these are to find the variables. And when you define variables, you want to use as many words as possible. You want to use almost a complete sentence. So pretend you're on a computer and you can copy and paste. So how much does each type of ticket cost? We are going to have two types of ticket. That's the first thing we need to figure out. So we have Jawa tickets and we have SandPeople tickets. So I like to pick descriptive letters for my variables. So I'm going to use red and a J for Jawa tickets, but not just a Jawa ticket. That's not what I was asked about. I was asked about the cost of a Jawa ticket. So J is going to be that full phrase, the cost of a Jawa, I don't know if it should be capitalized or not, so we'll make that capital, ticket. And then I have to show how we're measuring that cost. We're measuring that cost in dollars. Why? Because I don't know Star Wars currency. So then we could call the next one maybe P for SandPeople. This would be, we're going to copy this phrase down almost exactly, except replace Jawa with SandPeople. So this is the cost of a SandPeople ticket, also in dollars. Now, very often with these types of problems, your two variables are going to be very similar to one another. Only one key word is going to change things. Unfortunately, what I found is that a lot of people think that that key word is sufficient for writing their variable, and it isn't. It is an indicator as to which variable goes with which piece of the problem, but it is not sufficient as a variable all by itself. You will lose points on any test if you just write one word for your variable. So step 2, now that we have our variables, is to figure out what our equations are going to be. Now, in each of these problems, we're going to have two different cases or two different scenarios. And I like to label my equations with those scenario thoughts. So if I come in and look here, I see I've got Jabba the Hutt doing something. And I've got, pick a different color, let's do black, I guess. I've got Boba Fett doing something else. And they're doing something similar, right? They're both selling tickets to this event. but they sell different amounts of tickets. So when I write my equations, I like to, as a side note, describe for myself what the equations are going to mean. So I might do that over here to the right and say this is going to be my, let's make this in order. We'll call this one my Java equation. And so below it will be my boba equation. So for my Java equation, he has sold 4 Jawa tickets and 3 SandPeople tickets for $18. And so I can use the variables that I've already created and say if he sells 4 times the price of a Jawa ticket plus 3 times the price of a SandPeople ticket, he brings in $18. So yes, this looks like 4 Java tickets plus 3 SandPeople tickets equals $18, but if I'm not letting the J and the P represent the price of those tickets, there's no way I'm going to get out the $18. So similarly, the Boba Fett equation would look like 3 of the Jawa tickets plus 5 of the SandPeople tickets is going to give him $24.50. The overall equation that we're writing here is number of tickets times the price per ticket plus the number of tickets times the other price per tickets is going to give us our total, I don't know, total income, I guess. So if you follow this thought, it works for both equations. Number of tickets times the price per ticket plus number of tickets times the price per ticket equals the total amount that Java brings in. So this is why our units are so important. We need to be able to have matching things in order to work with them. So the next part of this is going to be to solve my system. So I almost always recopy my equations down just so I have them handy to work with. So I've got 4j plus 3p equals 18. And I have 3j plus 5p equals 2450. Now you might recall that we have 2 ways of solving a system of equations. We could either use substitution or elimination. When I look at these equations, neither variable is easy to isolate. Neither variable has a coefficient of 1 or -1 anywhere in my system. So I am probably going to default to elimination. And the reason I'm defaulting to elimination is that I will have fewer fractions. And I know you, as a Math 95 student, you like it when we have fewer fractions. I don't mind them so much, but when you can clear them, it's nice. So I need to multiply both of my equations. First, we need to choose which variable to eliminate. And you should know by now it doesn't matter. So let's eliminate the Jawa tickets. Sure, why not? So I need to multiply this top equation by a -3, and this bottom equation by a 4. When I do that, I'm going to get out a new set of equations. So this will give me, I'll have a -12j minus 9p equals, let's see, 3 times 18 is going to be 54. and this would be a negative 54. I almost missed that one. So I'm just distributing that 3 through to all 3 pieces. Same thing with this 4 down here. I've got a 12j plus a 20p is going to give me, okay, 4 times 24, 50. That's almost 4 times 25. So 4 times 25 would be 100. I'm subtract $2. I get 98. I'm hoping this is right. I am doing this arithmetic in my head, so we'll see. And when I add these two equations together, j's cancel, so that's gone. I wind up with a negative 9p plus 20p, so that's 11p should equal, and the 98 minus the 54, that's what I'm going to have right here. That gives me, so 8 minus 4 is 4, 9 minus 5 is 4, 11p equals 44, so p would equal $4. So now that I have that my p equals $4, I need to figure out what my j is going to equal. So I'm going to pick that piece up, and I'm going to plug it into one of my 2 original equations, and it doesn't matter which one. So I'm going to go ahead and go for Jawas equation. So let me write that down. Jawas says that 4j plus 3 times the SandPeople ticket cost, which was $4, should equal 18. I am going to solve this equation for j at this point. So 4j plus 12 equals 18, which is going to give me that 4j, I don't know why I'm avoiding that box, I should just click it out. So 4j equals 6, j equals 6 over 4, which is 3 over 2, which in money is $1.50. So j equals $1.50. And then of course we're going to check. So we've used the Java equation to get our Jawa ticket prices. So I am going to check in my Boba the Fett equation. So I am going to grab my 3j, 3 times 150, plus 5 times my 4 should equal 2450. 3 times 150 is going to be 450. 5 times 4 is 20. And, well, look at that. That does equal 2450. We were correct. So then the last step is to write a sentence answering the question. So to do that, we would simply state that Jawa tickets cost $1.50 each, and SandPeople tickets cost $4 each. And if this were a real-life situation, not a Star Wars situation, we'd be able to check to make sure that that makes sense. Just to do a quick reasonableness check, and we can compare it to the numbers that we have and see that this actually does sort of make a little bit of sense, even though it's sci-fi. So now that we have this problem done, I'm going to go ahead and pause the video. I'll start us up in another video, and I will tell you which problem it is that we're going to solve. This is the new way that I am going to be recording these from here on out.